Good afternoon, everyone. Thanks for coming. It's actually very nice to be here. It's my first time in Poland, and I'm delighted because I can finally wear shorts. I'm located in Finland, and we never have temperatures like this. There's been, I think, 4 years, and in Finland we still haven't reached those temperatures. So it's cool. The only time we have those temperatures is in the sauna, but that's another topic of discussion. I'm technical evangelist with AWS. I've been with AWS for about 3 years, and I worked with AWS technology for about 11 years. So actually, at the very beginning, started to work with AWS when they started to launch their services, and I haven't stopped since then. And for the last 3 years, I've been mostly focused on traveling the world, meeting customers, and helping customers build their architectures and especially scale their applications and architectures. And today this talk is kind of a collection of some of the coolest patterns I've seen, and all the patterns I will highlight them with some demos. Right. So the first thing I want to say is we need to pray for all the demo gods. We have about 4 or 5 demos, and they all involve you. All right. So you're all going to be interactive and you using those demos. So I'm going to have you need your phone as well, so prepare, warm up your phone. At least it's the first time I think someone asks you to use your phone during a presentation, but that's for the good thing. We're going to focus on a couple of things, especially 3 things, 3 patterns with several demos for each of those patterns. And they all relate to data. At least for me, the biggest kind of common denominator that I see with customers when I talk to them, from the very small startup to some of the largest companies in the world, gaming companies or enterprise, they all are interested into data, right? That data is the most important because the more data you have, the better decisions you can make. So if I would say the most important thing about a business is data. And there's a few things that you can do, especially in the cloud, to collect data and to make better decisions. And of course, real-time analytics is one of them. Right? We're going to look as well at how Internet of Things and IoT can help you gather data and actually in real time to make better decisions and interact with it and see what we can build. Internet of Things is, of course, about sensors, but there's a lot of other stuff you can do, and we're going to have a couple of demos around that. And then, of course, machine learning, which is kind of, what's coming, is kind of using old data to make predictions about the futures and things like this. So there's a lot of cool stuff that is happening in the space. So hopefully you get some ideas of what you can build and what you can do. I'm going to show some of the code as well. If you are not comfortable, just raise your hand, ask questions. Let's make it interactive. I'd much rather have an interactive discussion than just come, show up, present, and leave. For me, it's cool sometimes as well to talk. I spend my life traveling and talking, so having interactions is actually sometimes fun. Let's start with real-time streaming, right? And real-time streaming, really, for me, the most important thing that you need to think is bring data to the cloud and make decisions. And there's 3 things, right? The ingestion process is like take your data, pushing it. Then the way of going there, so the way, the stream, and especially during the streaming, like how you when you transfer the data, act on it as it being transferred, and then eventually store it and then do the analytics there. So in AWS, there's especially one service that is interesting. I'm not going to go too much into marketing slides and stuff like this. I just showed this one because it's important concepts. I think a lot of people think about streaming and then don't really understand the concepts when I'm defining this. So I added this slide so just you know what I'm talking about. Kinesis is very simple. It's like a motorway. Right? You're going from one city to another, and there's lines, and your lines basically can only take a certain number of cars per hour, right? And we call these lines on Kinesis a shard. Similarly, then the shard into a database. The more you want to transfer data to the destination, the more shards you need to add, right? And to handle this streaming on AWS is really Kinesis. Like, Kinesis is the real-time kind of service to send data, okay? And you can add as many shards as you want, right? We have customers having 10,000s of shards. Those are some of the biggest. In fact, the entire Amazon.com website, analytics, logs, and billing is being sent in real time to Kinesis. And we're talking about hundreds of thousands of shards, right? So that's a lot of data. And what you can do is, of course, send the data, and then Kinesis streams have several flavors. The one we're using today is you have producers, you produce the data, Kinesis stream that receives the data, and then you can use a tool called Kinesis Analytics that allows you to run live SQL statement on the data being sent, right? And then that data is often used to further send over Spark, EMR, to do, for example, very advanced machine learning, or EC2 or Lambda if you want to act on the data fast. And one customer that is doing that is kind of Supercell. How many of you have played once in your life a game from Supercell? Like Clash of Clans, Clash Royale, Heyday, Boombox, things like this. All those are games done by Supercell. In fact, it's the biggest or the longest game provider that has been in the top 10 of games ever sold. Daily, they manage about 100 million users, right, on their platform. And this is one of their last game, which is Clash Royale. And you see there are cards on top, right? There are cards. And what they do, users select those cards to attack the other one, right? So one-on-one, and you select a card and you say, oh, I'm going to attack and hopefully kill my opponent. And the whole purpose of this game for Supercell is to sell cards, right, that are good for the users. So what they do is they collect in real time information about the user, the behavior, what they do, how they play, and they do real-time analytics and then do some machine learning to be able to give you a recommendation of what cards you should use in your system. And this is kind of the architecture, high-level architectures they do. As I said, they have 4 games currently in use in the stores, and they use about 5,000 plus instances on AWS to run all their games. 600 of them are actually databases as well. And they use thousands of Kinesis shards to send real-time data. In fact, per day, they send 45 billion game events about all their users. 45 billion, right, on which they do real-time analytics. So it's a big, big, big platform. In fact, it's one of the biggest game companies on AWS, right? And what they do, they have 2 pipelines. They have a pipeline that, from the top, where they use Elasticsearch and DynamoDB to store data and to do some real-time analytics. And then there's another pipeline where they send the data into S3 and do some very deep machine learning. And these are kind of the results they managed to do with real-time Kinesis analytics, and using Kinesis to send real-time data and do machine learning, is they're able to target, to increase the purchase rate by over 4 times, right? So it's a massive difference doing machine learning than just offer random cards to their user to select and play. And in fact, they also understand where, as a user, you spend time in the game. And if you struggle, they are able to adapt the level of the game, or the difficulty of the game, so that you don't stop the game. Right? If you spend a little bit too much time, very often people say, oh, that's too difficult, and then they stop playing and they never come back. At that very moment, when they think that you will give up, they make you give you some hope and make the game a little easier. And all this is done using real-time data. So if you ask me, real-time data is that important? Pretty much, right? Because that's the entire business model of the companies. In fact, many companies are using this. And I want to show you some of those pipelines and some of the demos. So here is where you should use your phone and actually go on the website, and I will demo you what it is, a real-time pipeline analytics. So if you can go on this website with your phone or take the QR code, you will be directed directly to the demo. Once you have the demo, you should be having a quadrant like it's like this. Give me a thumbs up so I know, especially in the back, that you are there. Thumbs up. Still a few of you are trying to collect, right? So if we go to the website, this is what you should see. And in fact, this is some of the real-time dashboard of what's happening here in this room. We have now about 80, 90 users in real time. And it's quite funny because very often when you start the demo like this, it's always the blue or the green that are higher, BOs or these. Never A, never C. Right? So it's interesting. In fact, blue and green are preferred color for most of the people, so it's interesting. Now, just to show you how fast we can go, actually, it's a very big proportion of Android phones there. It's the first time I see that big proportion of Android phones as well. It's cool. There's no Windows phone. Not sure if it means something. So funny. There's always this one guy, usually, in the audience that has a Windows phone. You know this. It's so funny. Either he's not playing or something. Anyway, I'll stop my stupid jokes. Let's just go, everyone, on C. It's to see. So it's a couple of seconds, and then you'll see C will just jump. And this is really to show you how fast we can go. And now if I tell you, actually, when you play that quadrant, your phone is going through the mobile network or the Wi-Fi, goes to the US, right? My backend actually is in the US. Kinesis is in the US. There's Kinesis Analytics that does SQL statement in real time, stores that into DynamoDB, and then my laptop connects to DynamoDB in the US. So there's a lot of latency and round trip. Just here to the US is about 1 second, forth and back. So basically the whole analytic on the whole data is about a couple of seconds. And let's go all on A now to see. And you see it's updating every second, right? So remember that because I'll explain why it does that. There's this rebellion guys that are still pressing on B. Who are you? B and D. Who are the rebellious fingers? Cool. Oh, there's this Windows phone showed up. Who is it? Woo! Wow, we need to give you a round of applause, man. It's cool. Nice. I love it. I'll give you some AWS credits. Just come to see me at the end. $100 of AWS credits just because you assumed your Windows phone is good. I used to have Windows phone, actually. I thought they were really good. I used to work at Nokia, so when Microsoft bought, we all got Windows phone. I wouldn't have bought it otherwise. So this is the pipeline that I just demoed. Actually, it's very simple. And here you see in the title of the talk, it's called Serverless. And this is exactly a serverless pipeline, right? So there's absolutely no servers happening. Let me tell you a little bit how things go, because it might be a little bit weird. I'll start with Cognito. Right? Cognito is a service to be able to authenticate to a system. And now you say, okay, well, but I didn't authenticate. And you're right, you didn't. But Cognito supports unauthenticated connections, right? And I'll show you quickly what it means. Like, so this is Cognito, and what you do in Cognito, you could create what we call federated identity and user pools, right? And user pools, it's an ID that I can put users and things like this. But I can also create especially roles that can be defined. What can this identity pool do? And you see, here, this pool supports unauthenticated role, right? And that means that you still will use Cognito, but unauthenticated. So when your application, when you go on the mobile app, there is a JavaScript SDK that is loaded in the mobile app that makes a call to Cognito and give you a unique ID, right? And that unique ID then as a policy which is here, right? So this policy allows me to do some put events in the mobile analytics. This is nothing relevant to you, but can connect. Oh no, this is the light bulb one. I'll show you then. Keep this in mind. is that you can do unauthenticated stuff, and you get a unique ID. Okay. Then what it does is the mobile app check the position of the round in your quadrant on your phone, and sends a JSON object to a Kinesis stream. It's just put event. And actually, the JavaScript API is very simple. So you see, this is my function, the JavaScript function that is used in your app. As I said, I'm getting credentials from Cognito Identity. So there you get a unique ID. Then I define my Kinesis target. Then I have a couple of functions that get the mobile operator and the orientation of the device, calculates where it is in the quadrant, and then creates an output of that. And this is exactly the JSON object that I was talking about, which is this one. So you see, I'm collecting the device, the OS, the sensor name, and some of the orientation and things like this. And then really quite simple. I call records, and then I push that record with a specific partition key there. Okay, and then that's it. And then it sends to Kinesis. And Kinesis puts this record on the stream. So it's very simple to use. As I said, this is about 150 lines of code. And this is pretty much the only kind of business logic in the app that is there. The rest is just orientations of the screen and things like this. So this JSON object is put into a Kinesis stream, and then this Kinesis stream pass through what we call Kinesis analytics. And Kinesis analytics is a tool that allows you to run real-time SQL queries. And instead of showing you a slide, I'll show you the tool itself. So here this is my whole pipeline. I have a source, which is the JSON object, and then it goes through this Kinesis analytics. And then you can click here, and you see here I have kind of SQL queries, SQL statement that kind of does all the processing. And do you see at the end of the room, or do you want me to make it a bit bigger? End of the room? It's fine? Cool. So it's quite simple. I'm collecting the data from the stream. I'm creating a unique, another stream inside analytics is the way. So you take a stream and you, what we call, do a pump. And then I take all this information from the JSON object, create a source that then I count. And that's the only business logic in the whole thing, is I count distinct users, so since you have a unique ID when you connect it to Cognito, and then unique user with the OS, which is Android, iOS, Windows Phone, and others. And I do the same with the quadrant. So this is very simple. And then this whole thing is actually inserted into what we call a destination stream, so another stream. So I take a stream, I have a source stream, I do the analytics, and then I send the results into another stream. Okay? I have all the code in the slide, so you can have it when I'll give you all the slides as well. And well, these are some of the details. So this is there, and this is the counting, how things happen. And you see at the end here, there's a statement actually which calls floor round time 2 seconds. And this is exactly why we saw the refreshing of the data on the dashboard, because all the counting of the unique users, quadrant, and operating systems happen once a second. And it's different ways you could do it. You could use a tumbling window or a sliding window, depending on kind of the use case. One just is constantly reevaluated. The other one is just per time interval. So we are using the tumbling window for this demo. Sorry, I thought he was talking to me. And then the result is just sent to another Kinesis stream. And now you might say, how do I push this to DynamoDB? So the result is pushed to DynamoDB using a Lambda function. Lambda function, how many of you have used Lambda functions before on AWS? Right? So not so many. Lambda is a serverless compute. It's just a function. You don't anymore have to have a server running code. You don't have containers. You simply have a function. And that function is invoked either through a stream or directly. This is called AWS Lambda. It was launched in 2015. It's really a beautiful way of doing serverless computing. And that Lambda function is invoked every second. And every second, as you see in the code, it fetch data from Kinesis. You see record Kinesis data, and then it actually takes that and push this into a DynamoDB table. DynamoDB is a NoSQL database on AWS, so you don't have to manage anything. You just create a table, and that's pretty much it. You can push as much data as you want there. It scales automatically, and it will give you, even at very large scale, the same latency, very single-digit latency to access data. In fact, Amazon.com uses DynamoDB for most of its operation, and during Black Friday and Prime Days, the database goes at 14 million requests per second. So it's a good database. It's quite solid, if you ask me. So we take this JSON object from the Kinesis stream and then push this to DynamoDB. If you are doing this, you might remember that in Kinesis there are shards, and if you have several shards, you will have one Lambda function invoked for each of those shards, and for every second. So this is just the way it goes. If you want to process your Kinesis stream faster, you usually need to make more shards so that your Lambda functions can empty the Kinesis stream faster. And this is really a beautiful way to do your real-time analytics. And as I say, it was very, very fast. I don't have to maintain servers. I don't have to deploy anything. If I don't use the demo there, I pretty much don't pay for anything. Right? Everything is scaled down and then put to stop if it's not used. All right. Any questions related to this? If there are, I can also take them after. All right. So let's move to the second cool things where you want to manage data. And this is really Internet of Things. Internet of Things, of course, I think everyone has a lot of different definition of it. My definition is connecting the worlds, right? I get data from sensors, objects, people as well sometimes, so that we can make better decisions about the environment, about the business, what's going on. And really, on AWS, there is a service called AWS IoT, very original name. And there's a bunch of features which I want to talk about before doing the demos so that you understand what I mean when I do the demos. The first three features of this service is registry. Registry is simply a way to manage devices. In fact, the IoT service on AWS allows you to connect one device to millions of devices. And you don't have to do anything about it. We scale the entire infrastructure ourselves, so you don't have to manage this. If you make a POC with 1 or 2 devices, the same code can go to production with millions of devices without any problems. Right? And it allows you to really connect your devices very securely. Right? And I'll mention that later. The second thing, which is very, very important, and I'll show what I mean by this, is shadows. And very often is the most misunderstood terms when you talk about IoT. A shadow is a virtual representation of a device in the cloud. When you build applications, you never build applications against real devices, because if those devices go offline or don't have battery or lose connectivity, your application would be useless. So what we do is your application is calling what we call shadows. And the shadows are just images in the cloud of those devices. And when the devices are offline or getting back connected, then there is conflict resolution that is happening automatically on the platform. You never have to care with this. The platform, we take care of this. But it allows your application to be online, right? And always being able to manage the last known state of the devices. And this is very important, shadow. Rules in action is what you do on the devices, on the data, as it flows into the platform, okay? And that can be, take this data, forward it somewhere take this data, store it, take this data, transform it. There's a lot of different rules in action, predefined, that you can just click or enable through the API. And that's pretty neat. It's a pattern matching as well, so it's using pattern matching with SQL queries. The other key features is that the platform supports a bunch of different protocols. Of course, the standard MQTT. MQTT is a very lightweight protocol to send messages between devices and the platform. And it supports HTTP. But it also supports WebSocket, and especially MQTT over WebSockets. And why I say this is WebSocket is very cool because it allows you to have bidirectional connections. So all of a sudden, you don't only have devices talking to the cloud, but you have cloud talking to your devices. And this is a very good way to do updates on your devices, or generate logical actions on the devices if something happened in the cloud. Okay. And then, as I said, the device or the platform can really scale from 1 to billions of devices. And if you have connections between your devices, they will keep long-live open billions of connections. And building this yourself would be pretty hard, right? 15 years ago, when I moved to Finland, I worked at Nokia Research on integrating the home with the environment, with sensors. And it took us almost 6 months just to port a TCP/IP stack on the low operating system, like Contiki back in the day. And now, really, with a couple of lines of codes, you can do this. So the only thing you need to do here is download the SDK, put it in your devices, and you're ready to go. Right? It's the SDK manages the security of the devices. It's bidirectional connection with X509 certificates, so very state-of-the-art bidirectional securities. And these are kind of the patterns we see. Of course, this is a standard way of using the platform. You have collections of IoT sensors, and you send data in real time on the cloud. You do some actions. So, for example, store the data into S3, and then or push it into Kinesis. But this is kind of a standard way. What I want to show you is another way of using the platform in a very interactive way. Okay, so if you can take your device as well, and we'll do some demos. And this is using the concept of shadow, right? Give me a thumbs up when you have the light bulb on your device. You should see a light somewhere. It's at 0, right? Thumbs up if it's at 0. Cool. Good. Anyone still looking at the URL? We're good? All right. Let's go there. So you should see something like this, right? So I'll reload this because I didn't have the connection. And you should say on your device is connected to there. But the cool stuff is I have a bit different page. I have the master page of this. And with my master page, I can actually control all the devices that you have. And here you can see, and you should be able to see in real time updates on your phones, right? Do you have it? You can lift your phone up in the air so everyone see that it's affects in real time. It's cool. Now the cool stuff you can do with this is you can actually also, and this is the architecture. So before I go, this is the architecture. All your devices are connecting to a website which is stored on S3. S3 is our storage option where you can deliver an HTML page. All the slides will be available online, so don't worry taking a photo of the architecture. You'll have the PDF and everything. If you follow me on Twitter, I'll put them online right away after that. That's the way to increase your Twitter followers. Cheap. So the web page is downloaded, then there's an SDK that again connects to Cognito to get a role, and the role allows it to push data into the IoT platform. So now I can show you Cognito because this is the one I had prepared here. This is the role that my Cognito identity pool allows me to do, allows you to connect to the IoT platform, to any of those. And then you can publish and receive, but only on, you see, a particular topic. And this is the resources on the topic on where your device is allowed to connect, right? So this is a way to have unauthenticated connections, still having a user ID, but then controlling what you can do with this. And this is a very secure way to tight it. The worst way of using this is if you put an asterisk in resource. That means you can do pretty much anything with it, which you don't want. So if you start using this, make sure you define exactly what you're allowed to do with this. So this is my policy, and then I can start using IoT. So your device gets the Cognito ID, gets the policy, and is allowed to push data to connect to the IoT platform. And it doesn't push currently, you are just receiving, so it's actually subscribing to a change. And I want to show you what I mean by this. This is there. So I'll inspect, and this is the console, and you see the console actually is throwing things. So if I update this, and I go here on the console, you see there's a change that has been pushed. Here, my state reported brightness 0. This is kind of all the information is sent from the IoT to your devices. And if you take here, this is the whole topic on which you can connect. And you can verify the topic. So this is the IoT platform on AWS. There's a bunch of stuff. You see, you can manage your things. And this is my thing, which is the light bulb demo. And these are the shadows where I said that you can modify. If you want to edit this, you'll see I can put this to 20, and then you should be able to, it should update the data here. Or it doesn't here, as it's updated on the client. So that means you can start interacting with the device. But you see as well what is cool on the platform is that you have an MQTT client to start, and you can test your connections. Here I can put my topic on which your client is connected, and then I can start again, do some modification and see what is being sent. You see, this is the update of the state, and this is if you've seen the URL here on this one. It's an update of the shadow. You see, so my application updates the shadow. It doesn't update all your devices, right? They're just your devices are subscribed to a change of the shadow, and this is how you do mobile development against IoT devices. And every time there's an update, this is what is being sent, and then my device can update. And I want to show you quickly the code as well. This is the JavaScript library that allows me to connect to the IoT platform. So very similarly, I connect to Cognito to get this unique ID. I get the role. And then you see here, it actually subscribes to updates of the device shadow. And this IoT thing name just comes from the config file where I just have the name of the stuff, of the device. Oh, this is my device, okay? And then that's pretty much it. And then for every change of state, it's updating the function, set local state for the brightness. So when there's this new value is coming. It's just the light bulb in your device, just change its state. And this is very nice. And it's, of course, running on WebSockets. Okay. And this is pretty easy to do. Now, the cool things is you might see in this architecture is actually have a Lambda functions again. And that Lambda function allows me to connect Alexa. And Alexa is a product where you can do communication with it. You can talk, ask the weather, the traffic, and stuff like this. But you can also do custom skills. And then with these custom skills, you can call Lambda, and then Lambda will do the same thing. It will update the state of the shadow. And I want to show you a little demo. I don't have Alexa here because it's too heavy, but I have a simulator of Alexa, and I can start talking to Alexa. And Alexa, the skill is called Edison, so I'm going to call Edison. Edison, change brightness to 20%. I want to show you there. Okay, then the demo gods have finally showed up. That's good. Well, all right, let's try to change. That's actually the sponsor one that failed. I would have been surprised if everything would have worked out of the box. Ask Edison to update the brightness to 20%. All right, my device says, oh, no, it worked. It did. It did work, right? Yeah. All right, let's try to get this one because this is the one you have on your phone. Ask Edison to flash fast. So you can do pretty cool stuff, right? And again, this is simply using custom skills, and then have a Lambda functions that takes those intents from Alexa and then updates the state of the IoT shadow. So really nothing too critical if you're interested into seeing the skills. Here, this is my custom skills for Alexa to do the update of the shadow. This is pretty. It just collects intents, but the fun start is here is really the Lambda functions, which gets all the data from the Alexa skills, and then simply have functions to update the thing. Yeah. So you can get the thing, update thing shadows, and that's pretty much it. And again, this is about 200 lines of code, so really not that much. Now the cool stuff is that, again, I didn't have to deploy anything. If I don't use the platform, you pretty much don't pay for anything. All serverless, all managed for you. You can scale from 1 user to millions of users. You don't have any change to do in your code. It will scale automatically. And this is pretty cool, I think. But now the interactivity was not really to the top. I think the best is let's connect to this one because this is much more interactive. And now this is going to be the bidirectional connection. Yes? Yeah, just a second. Because now people are connecting there. Let's go. You got that? This one. Yeah, there's a question. Yeah. So the question was, if you're not using your phone, how does that affect, and you want to use any other devices, or Raspberry Pis, for example? So you don't have to do anything. This part of the architecture doesn't change. The only thing is you just load the SDK. And as I say, it's using standard MQTT protocol and WebSockets. So if you don't even have to use AWS SDK, you can use any of the libraries that you want that connects to an MQTT endpoint and being able to subscribe to change of that. So it's very standard protocol, nothing custom here. As I said, the whole platform supports MQTT WebSockets as standard. So you can just either use the SDK, which will manage security and all the certificates, or you can just do it yourself, depending on what you want to do. All right, so you all are here, hopefully, and this is, well, I have too many windows. And yeah, of course, and you should see this, and this is now the demo. So you can see in real time, actually, what's happening in the audience. We already have 60, 80 users, hundreds, 120 finger clicks per second. So this is the number of finger clicks per second. I was hoping Poland would be much faster as clicks per second. So let's try to wrap it up. Especially everyone clicks on the red, please, so that we can see how fast we are able to do that. So yeah. We are now at 100 votes per second. Everyone clicks on the blue just to see, let's transform this cube into a blue cube. Yeah, it takes a bit of time. You guys were really fast at filling up with red. So this is the kind of stuff, and this is, again, very similar platform, same SDK, same connection. Now, the only difference is everyone is able to update, right? So you also have power, and what you do is actually, my laptop now, especially this dashboard, is collecting all the change of what you sent on the topic, and I collect this per second, and then I do some analytics on top of it. And this is pretty straightforward. This is the architecture of the system. As I say, again, very, very small. What it does is all your devices, again, get a unique identifier from Cognito, and then sends all the data to IoT platform. And my own computer is actually, this dashboard does all the computation of taking all the requests that you've sent, number per second, and then update the dashboard with the number of colors. That's it. Nothing really special there. And this is still very cool, running MQTT over WebSocket in that example. So that's a good way to also build applications. Now let's quickly move to machine learning. I have 6 minutes left, and I would like to have some questions. And this is kind of the whole stack of all the machine learning services you can use on AWS, from very low level, if you do it yourself, algorithm and deep learning algorithm, to very high level services where it's really one line of code to, for example, start using services. And I'm going to show you a couple of those, which are very fun to build interactive application. The first one is recognition. Recognition allows you to send an image. So you send a reference of an image or an image directly to an API endpoint. And what it does is does object and scene detection, returns you a JSON object with all what it's found in the picture, with a percentage, which is the confidence score of how confident we are with the result of what we found. You can also do facial analysis. This will return a bounding box of the face with some of the things, whether it's happy, smiling, if it has beard, glasses, stuff like this. You can also support crowd. So if you have, this is me in India. I went to India a few months ago. That was actually really, really fun. 10 days in India, and we did this live. It was fun. I didn't get sick. Everyone told me I was going to get sick while going to India, but I didn't. It's fun. So when we launched the service, you could detect only 10 faces. Now you can detect up to 100 faces. And you see this is the front of a iPhone 5. So it's not very good quality. and still the service managed to perform quite well. There's some misses there, here and there, but still quite fun. Then it also allows you, the recognition allows you to create private collections. So if you have your own images with your own people, you can tag those images and those people. We store them, the vector of the face, not the image, in your private collection, and then you can do facial searches. Right? So you can see, is this new image already known and in my collection? Is it to someone I know? And things like this. And you can also do now text in images, and you see here this is the JSON object that is returned with the response, so you can detect all the text in images and do a bunch of fun stuff. Companies like Marinus Analytics use recognition in their systems to do human trafficking, and in fact, they managed to save about 5 people per week in their production environment, people that have been involved in human trafficking, right? Either young or so the people that are kidnapped and put into places in new countries without passport, and then pushed to do stuff that you probably don't want to do. And so it's very easy to use. Service is one API call. As I say here, if you want to detect the objects and what's in the image, you can use it like this, and it returns a kind of a JSON object. So really very easy to use. And the same if you want to detect faces, you can also use it like this. And what I want to show you is also Amazon Polly. Polly is a text-to-speech synthesizer. So you send it a voice, and it allows you to generate that voice. So hopefully you'll be able to hear.
What's the difference between a hippo and a zippo? One is really heavy, and the other is a little lighter.
Right, and this is generated voice. It's generated using deep learning. In fact, it's a LSTM deep learning algorithm that allows to do text-to-speech synthesizer. And there's a bunch of different voices that are supported. Now there's a cool thing that the system supports. People are still playing? Are you kidding me? Pink. Who is clicking on pink? Yeah, you deserve some AWS credits. Come and get them. What is cool with Polly is it supports SSML. And SSML is a markup language that you allow to do some transformation. For example, if you have a number in the text, you don't want to say, oh, my phone number is 3,675,000. You say, 3.35, so you want this kind of stuff. But you can also affect it to, for example, be a lot more human, like have breathing. And this is very fun. And I want to show you quickly, there's a cool video on YouTube, which is a real video with a real human voice. You know this one, the Rise and Shine?
Rise and shine. 6 a.m. and your hand can't make it to the alarm clock before the voices in your head start telling you that it's too early, too dark, and too cold to get out of bed.
Right, so this is not Polly, this is a real voice, right? So now I took this text, and actually you can synthesize it with Polly and listen what Polly can do. So I actually selected Johanna's voice.
And too cold to get out of bed. Aching muscles lie still in a rebellion, pretending not to hear your brain commanding them to move. A legion of voices are shouting their unanimous permission for you to hit that snooze button and go back to dreamland. But you didn't ask for their opinion. The voice you have chosen to listen to is one of defiance. The voice that says there was a reason you set that alarm in the first place. So sit up, put your feet on the floor, and don't look back. Because we've got work to do.
Right, and you see, you can even do stuff like this, right? You can do emphasis on certain words. So the last publication of Dan Brown actually has been, all the advertisement has been done using Polly, very interesting intonation. And if you're using the Duolingo application, it's also, all the voices are generated using Polly. So it's very, very human-like deep learning algorithm, and one line of code to call them. So this is stuff you can do pretty funny. Again, one line of code, you can synthesize the voice, and you can download the MP3 or have an open source stream. But let's do, you can don't all do it at the same time, because this is a demo that your phone will take a photo of you, send it to the system, and generate the voice. But I want to show you live how it looks like. So this is, where am I? Well, let's go there. So this system allows me to take a photo. I'll select a photo, and hopefully I don't select one of the crazy photos. This is always bad. Damn it. Let's put this. So I'm uploading a photo, and it's sending the photo to recognition.
Hi, my name is Polly. In this picture, I see two faces. The first face is a happy male between 29 and 45 years old. The second face is a happy female between 35 and 52 years old. I think I also see clothing, coat, overcoat, and suit.
So there's a bunch of stuff you can start doing, right? And as I said, this is literally 20 lines of code. And all the code is on GitHub, so you can also check it for yourself. And as I say, if you go on the website, you'll be able to test the demo. It's going to ask your phone to take a frontal camera and then generate the voice automatically and plays it for you. Usually I do this demo at the end, otherwise everybody starts the phone and then I don't hear anything anymore. But that was actually my last demo. This is how the architecture looks like. If you're interested, again, I'm using Cognito for the identity, and then simply 3 API calls, 2 to recognition. If it finds a face in the labels, then sends face analysis, and then generates the voice, and then plays the voice. And again, all serverless, all sitting on top of S3. You can use it as much as you want to millions, and I don't have to do anything with it. On that note, if you have questions, don't hesitate to hit me on Twitter or on my Medium, where I push a lot of information as well. And for those that actually were brave enough to start their Windows Phone and to click on pink, don't forget to come and get your AWS credits. Cool. Thank you very much. Have a good day.